Okay, so we begin the next test, and that is known as ratio test, and another is known as root test. Now see, what is the ratio test and root test? So here you are given series n equal to 1 to infinity an. This is given. Okay, and these are the positive terms. Positive terms. Now, in ratio test, find limit n tends to infinity an plus 1 upon an, and suppose that limit is say any number, say rho. Okay, same way in root test, you do like this. Find the limit n tends to infinity an power 1 upon n, and suppose that is rho. Okay, now for both the test, the conclusion is same. The conclusion is the series converges if this limit is less than 1. The series diverges if this limit is greater than 1 or infinite. And no conclusion if the limit is equal to 1. This is the theorem. It is known as ratio test and root test. Okay. So write down this. Write down this.
अलग सीखમાં આપણું કે પેલા આપણું ફોર્મેટ છે એમાં અલગ सीख બનાવી દો 10 દિવસ હા ને અપ્રૂવ થઈ ગયું એવું ભાવશે ભાઈ ચાલો એ બધું પ્રોસિજર ચાલુ કરો ચાલો
Written?
Yes, sir.
Okay, fine. So let us take the examples where we can use this theorem to check whether the series convergent or divergent. And we shall use the ratio test or root test. Okay. See, by practice, you will able to know when you can use the ratio test or root test. Okay. So it will be just by practice only you can able to know. Okay. But normally if there is a power, then you should use the root test. Power like we use, okay. Let us take some example. Check for the convergence or divergence, okay. The series you are given is like this: 2 power n plus 5 or 3 power n. Okay, so this is our series AN. Let us use, say, ratio test. What is a ratio test? Limit n tends to infinity AN plus 1 upon AN. Okay. So let us find limit n tends to infinity AN plus 1 upon AN. Limit n tends to infinity. What is AN plus 1? 2 power n plus 1 plus 5 upon 3 power n plus 1. And divide by AN. That means 2 power n plus 5 and upon 3 power n. So here you are having 3 power n. Understand everyone?
Yes, sir.
Okay. Now, limit n tends to infinity. So here we can do like this. Like here 2 power n we can take outside. What it remains is 2 plus 5 upon 2 power n. Yes or no?
Yes, sir.
Same way here 3 into 3 power n. This is 3 power n. Here also you can take 2 power n outside. So 1 plus 5 upon 2 power. So this 3 power n cancel, 2 power n also cancel. Now see, when you take n tends to infinity, this tends to 0. Agree or no? This also tends to 0. This also tends to 0. Because 2 power infinity, infinity and 1 upon infinity, so 0. So this is 2, 3 and 1. So it is 2 by 3. Now 2 by 3 is what? Less than 1 or greater than 1?
Less than 1.
Less than 1. So what is the conclusion?
Series is convergent.
So therefore you write like this: by ratio test, given series is convergent. Understand?
Yes, sir.
Write down them.
હેલો સર.
હા.
હા સર, આને જીઓમેટ્રિક શ્રેણી સિરીઝ થી પણ કરી શકાય ને સર? આ
How?
એક્ઝામ્પલ છે તો એને જીઓમેટ્રિક સિરીઝ થી કરી
થઈ
શકાય તો
જાય. હા,
એક્ઝામ માં
થઈ
ના
જાય.
પૂછ્યું હોય તો કોઈ પણ લખી શકે ને સર?
ચાલે, કોઈ પણ ચાલે.
હા.
Yes. Good. Then you are having like this. There are two series. Isn't it?
યસ સર.
Yeah, fine. Okay. Let us have one more example. Okay, I'm taking one more example. Okay. Have you written, everyone?
Yes, sir.
Okay. So let us have one more example. Test the convergence of summation n equal to 1 to infinity to n factorial upon n factorial n factorial. Whenever you are having like factorial kind of things, you should use the ratio test. So let us use the ratio test. So let us find the limit. An plus 1 upon an. So this is equal to limit n tends to infinity to n plus 1 factorial. This is n plus 1 factorial, n plus 1 factorial upon an. So this is 2n factorial upon n factorial, n factorial. Everyone understood this? An plus 1 upon an.
Yes, sir.
Okay. Okay. Now, limit n tends to infinity, we are using the property of factorial. This is 2n plus 2 factorial, isn't it? Two n plus 2 factorial. So can I say like this? 2n plus 2, 2n plus 1 into 2n factorial.
Yes, sir.
Okay, this n1 plus n plus 1 factorial, can we say n plus 1 into n factorial? This is n plus 1, n factorial. This is 2n factorial, n factorial, n factorial. Understood?
Yes, sir.
Okay. Now, these two cancel. This n factorial cancel, n factorial also cancel. What it remains is limit n tends to infinity. These two outside. So 2 into n plus 1. 2n plus 1 upon n plus 1, n plus 1. This n plus 1, n plus 1 also cancel. So this is equal to limit n tends to infinity 2. Then let us take 2 outside, no 2, n outside. So this is 2 plus 1 by n. This is 1 plus 1 by n, isn't it? If I take n outside. And so this is 2 and this 2. So that is 4. So what is the conclusion now?
Divergence.
Because it is greater than 1. And therefore, by ratio test, series n equal to 1 to infinity to n factorial upon n factorial is divergent. Understood, everyone?
Yes, sir.
Okay. So if you have not written, write down. Written?
Yes, sir.
Okay. Next, let us see where we can use the okay. Check for convergence. Series n equal to 0 to infinity n factorial upon 5 power n. Okay. So now let us use the ratio test. So this is an. Now we find limit n tends to infinity an plus 1 upon an. So limit n tends to infinity n plus 1 factorial upon 5 power n plus 1 upon an. That means n factorial and 5 power n. So this is equal to limit n tends to infinity n plus 1 n factorial 5 power n. This is 5 into 5 power n n factorial. This 5 power n cancel, sorry, n factorial cancel. So what it have, limit n tends to infinity n plus 1 upon 5. What is the limit? What is the limit? Hello? What is the limit here?
Infinity.
Infinity. What is the conclusion? Here, see the mention here. Even if it is infinity, then also it is divergent. Okay. So therefore, by ratio test, series n equal to 0 to infinity n factorial upon 5 power n is divergent. Okay, understood?
Yes, sir.
Okay. Let us have one more example. Check for convergence. Sigma n equal to say 2 to infinity n square upon 2n minus 1 factorial. So let us see this one an. So let us find limit n tends to infinity an plus 1 upon an. So limit n tends to infinity. Now an plus 1. So this is n plus 1 square. Upon this is 2n plus 1 minus 1 factorial. This is an plus 1 upon an. So this is n square 2n minus 1 factorial. Understood?
Yes, sir.
Okay. This is what? 2n plus 2 minus 1. So 2n plus 1. Yes or no?
Yes, sir.
Okay. Can I do like this? Limit n tends to infinity. Here take n outside. So n square outside. 1 plus 1 upon n square. This is 2n minus 1 factorial. Now this is 2n plus 1 factorial. So can I write 2n plus 1? to n and then to n minus 1 factorial. And this is n square. Yes or no?
Yes.
Okay. Now cut the terms and then find the limit like this. N square and 2n minus 1 factorial. One minute. Yeah. N tends to infinity, isn't it? So what is that here? 2n plus 1. Okay. Fine. Correct. No problem. What is the limit here? What
0.
is numerator limit? Yeah. Numerator is 1, isn't it? But denominator is infinity. And this limit is 0. You understand, everyone?
Yes, sir.
Okay. Now what is 0? If 0, then what is the conclusion?
So no conclusion. Sorry.
Convergent.
Eh?
So it is convergent.
Yeah. Convergent. Why? Because 0 is less than 1. 0 is less than 1. So that is convergent. So therefore, by ratio test, series n equal to 2 to infinity and square upon 2n minus 1 factorial is convergent. Understand? You may write down if you wish.
Yes, sir.
Written. Next, see, let us use the root test. Say like check for the convergence. Series n equal to 1 to infinity and square upon 2 power n. Okay. Now, so this is an. Okay. Let us have limit n tends to infinity an power 1 upon n. So as I told you, see the power here is there. So limit n tends to infinity. Same example can be solved more than one way also. Okay. So here you are having like this. N square 2 power n power 1 upon n. This is n power. Can I write n power 1 upon n power 2 n by 2. Now there is one standard limit. You can prove it also. Okay. That limit n tends to infinity. N power 1 upon n is 1. You can use L'Hopital rule and then try to find out. This is infinity power 0 form. And you can check this. This limit is 1. So this limit is 1. And power 2. So it is 1 by 2. And this is less than 1. And therefore by root test, this series is convergent. You can use the same example by ratio test also. You can solve this example by ratio test also. Okay, everyone?
Yes, sir.
Yes, sir.
Okay. Okay. Next, so check for convergence of series n equal to 1 to infinity n power n upon 3 power 1 plus 2n. Okay, let us see. This is series an. Let us have limit n tends to infinity an power 1. Limit n tends to infinity n power 1 upon n. Okay. Everything. N power n upon 3 into 3 power 2n power 1 upon n. I can write in this way. So limit n tends to infinity, this is n. This is 3. And this is what? 9. Agree or no?
Yes. Sir, 3 power 1 by n आएगा.
Yeah, this is 3 power 6. 3 power 1 plus 2n, isn't it? So can I write this is 3 into 3 power 2n?
Yes.
Okay. Then
n
if it is
square
power
हो
1
तो
by n. Yeah, correct. If it is power 1 by n, then correct, you are correct.
ये तो n square હોય તો નો આવે સર.
No, you are correct. I can write in another way. આને મારે આમ નથી કરવાની જરૂર. I have to change. Correct. Okay. So here you are having 3 power 1 plus 2n only. Okay. Now limit n tends to infinity, n power 1 upon n. So that is n is correct. And can I write this 3 power 1 by n plus 2? Yes or no?
Yes, sir.
Agree? Fine. Now, what is the limit now? This limit is infinity upon 3 square. N tends to infinity. So this tends to infinity. N tends to infinity, this tends to 0. So 3 power 0 plus 2. So 3 power. You understand? So this is infinity greater than 1. And therefore, by root test, series n equal to 1 to infinity, n power n upon 3 power 1 plus 2n is divergent. You understand?
Yes, sir.
Okay. Next, let us check for convergence. Series n equal to 0 to infinity, phi n minus 3n cube upon 7n cube plus 2 power n. So this is clearly the use of root test. So limit n tends to infinity, an power 1 upon. Okay, limit n tends to infinity, a n power 1 upon n. And so this is equal to limit n tends to infinity, phi n minus 3n cube on 7n cube plus 2 power n and power 1 by n. And so this is equal to limit n tends to infinity, phi n minus 3n cube upon 7n cube plus 2. Now you can easily find the limit. Limit n tends to infinity, phi by n square minus 3. You can take n cube outside. 7 plus 2 by n cube. What is that limit now?
minus 3
Minus
by
3 by
7.
minus 3 by 7. Okay. And which is less than 1. Which is less than 1 minute. Yeah. Yeah. So by root test, series divergent. Okay. Convergence. Sorry.
Convergence.
Convergent. Understood? Everyone, the examples are here.
Yes, sir.
Hello. Okay. So these are certain examples where you can use the ratio test, root test, or kind of things. Okay. Even as I told you, some examples you can use even same example you can use both the test. Okay. Let us have one more example. Series n equal to 1 to infinity, n plus 1 power n upon n factorial. So see, factorial, that means you need to use the ratio test. Because n factorial power 1 upon n, you don't have anything. Okay. But this limit you know. આની જરૂર પડે તો આપણી પાસે છે. Okay. So let us use the ratio test. So limit n tends to infinity, an plus 1 upon an. So limit n tends to infinity. What is an plus 1? N plus 1 plus
Plus
1, isn't it? And power n plus 1. N plus 1 factorial. This is n plus 1 power n. N factorial. Isn't it? So next limit n tends to infinity. Now you can do like this. This. See, there is one limit we can use. 1 plus 1 upon n power n. That limit is e. We are using this. Let us see how we are using it. Can I do like this? 1 plus n plus 1. Okay, let us have These two you can easily make it cancel, and this is n plus 2 into n plus 2 power n. Let us see. Can I write in this way? N plus 2 power n factorial n plus 1 into n factorial n plus 1 power n. Agree? So this n factorial cancel. Okay. Fine. One more thing is that this is equal to limit n tends to infinity. This is n plus 2 upon n plus 1 into limit n tends to infinity. Let us take n outside. So n power n outside. 1 plus 2 by n power n. Here also n outside. 1 plus 1 by n power n. Agree or no?
Yes, sir.
What is this limit? આ લિમિટ શું થાય? આમ તો તમે જો તો ઇન્ફિનિટી બાય ઇન્ફિનિટી છે, તો તમે બંને બાજુ ડેરિવેટિવ વિથ રિસ્પેક્ટ ટુ n કરો તો પણ આવે, અથવા n આઉટસાઇડ લઈ લો તો પણ આવી જાય લિમિટ લાઈક ધીસ. હવે જોજો હા, 1 plus 2 by n. Can I write this is n by 2 n multiplied? Why? Because, and this is 1 plus 1 upon n power n. આવું કેમ યુઝ કર્યું? કારણ કે મને આ લિમિટનો યુઝ કરવો છે. એટલે અહીંયા 1 by n છે તો અહીંયા ઉપર n છે, તો અહીંયા 2 by n હોય તો અહીંયા n by 2 હોવા જોઈએ. હવે મેં n by 2 કર્યા તો મારે 2 અહીંયા મલ્ટીપ્લાય. તો this is standard limit. વેલ્યુ e આવશે. આ પણ સ્ટાન્ડર્ડ લિમિટ જેની વેલ્યુ e આવશે. આ 1 આવશે. This is e square. This is e. Okay, and limit is e. Understand?
Yes, sir.
Yeah. So what is e now? What is the conclusion?
Greater than.
Greater than 1. And therefore, by ratio test, series is n equal to 1 to infinity n plus 1 power n upon n factorial is divergent. You understand? If you want, you can write. Written?
Yes, sir.
Yes.
Check for convergence. Series n equal to say 2 to infinity 1 upon log n power n. So this is series an. Now let us use root test. So limit n tends to infinity an power 1. So limit n tends to infinity 1 upon log n power n power 1 by n. So So limit n tends to infinity 1 upon log n. Understand? Now what is this limit? What is this limit?
Zero.
0. And so that is less than 1. Therefore, by root test, series n equal to 2 to infinity 1 upon log n power n is convergent. Okay? Like check for convergence. The series n equal to 1 to infinity 1 upon 1 plus 1 by n power n square. So this is series an. Now you take limit n tends to infinity an power 1. So limit n tends to infinity 1 upon 1 plus 1 upon n square and power 1 upon n. So 1 n cancel here. What it remains? One plus 1 upon n power n. Agree or no?
Yes, sir.
So this is 1 upon e.
Less than 1.
Standard limit e. And 1 upon e is less than 1. And therefore by root test, series is convergent. You understand, everyone?
Yes, sir.
Yes, sir.